Hi friends, and welcome to Chapter 5, Section 7, Subtract Linear Expressions. So last lesson we were adding linear expressions and it wasn't too bad. It was very similar to just combining like terms, and that was it. This one has an extra trick to it. Okay, so we're just going to write it down. Bring this closer so I can see. The big difference for today is before we can combine like terms, we have to distribute the negative, which is the same thing as the subtract from the middle, through the second parentheses. Okay, so again, big difference. So last time we had something 6x plus 3, and last time we had plus 2x plus 2. Okay, that's adding linear expressions. Today we are subtracting linear expressions. Okay, now to make this hopefully make a little bit of sense, again, we can rewrite subtracting as adding the additive inverse. So 6x plus 3 plus negative, and it's just a minus, right? So remember, we've got kind of the new term that I learned from Mrs. Drury is that there's a ninja 1 in there. Ninja 1. It's a ninja because we can't see it. We don't see it, but it's there. This just means it's a negative 1 times everybody in the second. Now, the 1 doesn't change the value. The negative has a big effect. Okay, so can you see the idea that we need to rewrite the subtracting as adding the negative? And now you can see we've got something we need to distribute through. And I'm going to go from here. We have to distribute that negative 1 through to everybody in the second parentheses. So 6x plus 3 plus, and I guess we can take away the parentheses. We don't need them anymore. Plus negative 1 times 2x is going to be negative 2x. And negative 1 times 2 is negative 2. See, both of these started out positive, and when we multiply them by a negative 1, it just turns them both negative. This is the key. This is what has to happen on every problem. You will make mistakes. So you really have to pay attention whether the number in the middle of the linear expressions is an addition or a subtraction. Okay, from here we can do our combining like terms, no problem. We've got 6x and negative 2x, which comes together to be 4x. Then we've got 3 and negative 2, which is 1. Okay, but again, this idea is the key. Let's try another one. 2x minus 3 minus x minus 2. Okay, so I really do think the easiest way to think of this is to just rewrite it with instead of subtracting, we're adding negative 1. Sorry, I didn't mean to move the papers over there. So just want to make sure I get all of the different kinds of examples done. Okay. So really, this is 2x minus 3 plus negative 1 times x minus 2. Okay, again, we're just rewriting this subtract as adding a negative. Now we need to distribute that negative 1 through the second parentheses. So we've got 2x minus 3, that one doesn't change, plus negative 1 times a positive x is negative x, and negative 1 times negative 2, because remember, anytime we have a subtract, it's really attached to that number that comes after. So negative 1 times negative 2 is positive 2. Okay, from there, we can combine our like terms. 2x plus negative 1x leaves us with just x. And then we've got negative 3 plus 2 is negative 1, or minus 1. Okay, hopefully you're seeing the pattern. We're going to need to do a lot of practicing on this to feel comfortable with it. Next one, negative 2x minus 4. We already have lots of negatives going on, don't we? And then minus 2x. So this one's kind of funny just because the linear expression doesn't have the second linear expression doesn't have a constant with it, so it looks a little different than what we're used to. But it all works out. Let's rewrite the subtracting as adding the negative. Negative 2x minus 4, that one doesn't change, plus negative 1 times 2x. Okay, so this one doesn't change, negative 2x minus 4, and then plus negative 1 times 2x makes negative 2x. Okay, hopefully that makes sense. Really, again, multiplying by negative 1 just changes the sign. So if it was positive, it's now negative. If it was negative, it's now positive. Just changes the sign. Now we combine our like terms. Negative 2x and negative 2x is negative 4x. And then this is the only constant, minus 4. All right, we're doing okay, hopefully. Let me know if you have questions. I'm happy to help. All right, now sometimes we can even throw in, it'll be not just a negative 1, but it'll be a number on the outside that we have to distribute through as well. So 4x minus 3 minus 2 times 2x plus 7. Okay. I'm hoping at this point I don't need to do the rewriting that I did on the first 3. I just want you guys to think that this is a plus and then put that in parentheses in your brain. Okay, this means we have to distribute negative 2 all the way through the second parentheses. So 4x minus 3, I guess I don't need the parentheses now that I'm doing the distributing. And then we've got negative 2 times 2x. So negative 2 times 2 is negative 4 with an x. And then we've got negative 2 times positive 7, which is negative 14. Alrighty, so let's go ahead and combine our like terms. We've got a 4x minus 4x. Those are additive inverses. Remember, that's when you start at 1 and then you go down the opposite of it and it gets you to 0. So really we have 0x, which is 0, and we're not even going to write that because we don't need to, because it doesn't change our value because of the additive identity. Okay, so now we just have to deal with our constants. We've got negative 3 plus negative 14, which is negative 17. Done and done. All right. Let's practice one more like this, and then I'll show you a story problem. As you know, the book likes its story problems. 6m plus 3 minus 5m minus 2. Actually, this is the story problem. Let me read you the story problem. It says, here, I'll pull my papers out and you can read along with me. Okay, hat store tracks the sales of college and professional team hats for M months. So the number of months is the variable M. The number of college hats sold is represented by 6M plus 3. The number of professional hats sold is represented by 5M minus 2. Write an expression to show how many more college hats were sold than professional hats. Okay, how many more is our Q word that we need to be subtracting? Okay, or it might say the difference. Difference means subtracting, all of that stuff. So first we need to find an expression, and then we want to evaluate it if M equals 10, so if it's at 10 months. So I've already written that expression down. So many papers. All right, so this was the college hats, and this is the professional hats. So first we want to simplify this to make all the math easier. In order to simplify it, we have to distribute this negative through. Okay, again, if you want to think of it as -1, if that helps you, you could totally just do that. So the first one doesn't change, 6m plus 3. Then we've got -1 times 5n becomes -5m. And -1 times -2, because that's a minus, right? Minus and negative. Negative times a negative is positive, so that becomes +2. All right. So this, again, we're calculating the difference between college hats and professional hats. So 6m minus 5m, 6 minus 5 is just 1. We don't write 1, ninja 1. So there's a ninja 1 in front. You just can't see it. And then we look at our coefficients, and we can add those together, m plus 5. So that's our simplified expression. See how much easier plugging a number in will be to this expression rather than this expression? Makes a lot more sense to simplify first. Okay, then it wanted us to evaluate if m equals 10 months. So we put a 10 in for m, and the difference between the two hats is 15. Okay, that's a lot easier than putting 10 in up here and then having to do all that math. So, highly recommend simplifying first. Yep, I think on most of them they give you the expressions. So I think you'll be all right. Good luck.